Welcome back as we look at more graphs of rational functions. Last time we graphed f of x equals 4x divided by x squared minus 9. We're going to start with just a tiny change. We're going to say 4x squared divided by x squared minus 9. So first of all, our domain. Remember that this factors into x plus 3 times x minus 3. So x cannot be 3. X cannot be negative 3. If I look at this factor, and up here there are no common factors, so no, it doesn't reduce. Intercepts, I plug in 0 for x and get 0 for y, and I'll get the same thing when I plug in 0 for y, nothing new. Symmetry, can you tell we're going to have y-axis symmetry? Let's come off here and look. Looking for y-axis symmetry, I'm going to use opposite of x everywhere I have an x. Well, when I square an opposite of x, I just have my x squared back. When I square this opposite of x, I have my x squared back. Can you see that that is actually our original f of x? So we have y-axis symmetry. Asymptotes, x equals 3, x equals negative 3. Since our problem didn't reduce away, we know they're asymptotes rather than an empty hole where x is 3 and x is negative 3. Let's go for our horizontal. Those were verticals. Now our horizontal asymptote is going to be y equals, if I start dividing lead term into lead term, it goes 4 times. So when I divide, I'm going to get 4 plus a remainder. Now I know that because once I'm down to the constant, the next thing is the remainder, isn't it? So the remainder over x squared minus 3 will approach 0 when x approaches positive or negative infinity. So y equals 4. And I caught that by just dividing lead term by lead term, and it turned out to be a constant. So that was an easy one. Does it cross that asymptote? Well, let's get some workspace here and see. If it crosses, then the y of this function, which is 4x squared divided by x squared minus 9, will equal the y of the asymptote, horizontal asymptote, at some point. So let's see how this works out. We will multiply both sides by x squared minus 9 since we have an equation, and get rid of fractions. So that reduces to 1, and I have 4x squared equals 4x squared minus 9. Let's get all the x squares on one side. So if I subtract 4x squared from both sides, I get 0 equals negative 9, which is always false. So no, we do not cross our horizontal asymptote, and we never cross the vertical ones. We'll decide what additional points we want as we graph what we have. So let's go now to a graph screen and graph in or draw in what we have so far. So far we have asymptotes at x equals 3, x equals negative 3, and at y equals 4. Let's look back and get a little bit of information here. All right, x, and we don't cross the horizontal asymptote anywhere, and we have the point 0, 0 to graph. So let's graph 0, 0, and we're not crossing any asymptotes whatsoever. So that means we need some values over here in the right-hand section, the middle section of the graph, and the left-hand section of the graph. So let's pick some numbers to plug in. On the right-hand section, I might pick 4 and 5 for x. In the middle section, I might pick a 2 and a -2. Then the left-hand section, I might pick a -4 and a -5 for x. Again, I want to put up the equation so we can see our symmetry at work for us. So our equation was y, or f of x, equals 4x squared divided by x squared minus 9. Now when I plug in 4 and work it out, I end up with 64/7, which when I get ready to graph it, I'm going to call it 9 1/7. Now if I plug in 4 here and 4 here, I'll get the same thing I get when I plug in -4 here and -4 here, won't I? Because the square of a number and its opposite is the same. So -4 is also going to be 9 1/7 in mixed number form. If I plug in 5, I get 6 1/4 in mixed number form. That means for -5, I get 6 1/4 in mixed number form. For 2, I get 3 1/5. -3 1/5 rather. So for -2, I have -3 1/5. So let's plot that. 4 and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 9 1/7. Let's just draw it in since it's so close. If it weren't close, I would put a scale on my graph. For 5, I get 6 1/4, so 4, 5, 6 1/4 right here. And since I know we're headed toward the asymptotes, which I will extend just a little bit here, I believe I can draw my graph just fine. It's going to look a lot like this. Since there's enough of it showing, I'm not going to go back and use a scale. All right, graphing on the other side, I have -4, 9 1/7. -5, 6 1/4. And again, I'll head toward my asymptotes. So we can see that y-axis symmetry. If I folded along that y-axis, those two sides would match, wouldn't they? All right, working on the middle, I'm going to do 2 and 1, 2, 3 1/5 down, -2 and 3 1/5 down, head toward the asymptotes here. And that's our graph. Now how did the other graph look? It actually went through the horizontal asymptote, didn't it? This one doesn't, so it changes a bit with an x squared as opposed to an x. Remember when we had the 4x in the numerator, we had origin symmetry. With the 4x squared in the numerator here, we have y-axis symmetry. Okay, we use the same denominator each time, had the same vertical asymptotes, but the horizontal asymptotes changed, the symmetry changed, and whether or not it crossed the horizontal asymptote changed. So that was kind of interesting, wasn't it? All right, let's move on and find us another one. There's our graph, and we're going to graph this time f of x equals 4x squared, again in the numerator, but we're going to change the denominator to x squared plus 1 this time. Wonder what that's going to look like. Well, let's get us a blank worksheet and work on it, and then we'll come back and graph it. So our f of x, or y, equals 4x squared divided by x squared plus 1. So first of all, for our domain, I square a number, I either get 0 or positive, and then I add 1 to either 0 or a positive number. I'm always positive in this denominator, right? I can't ever hit 0. So I can use all reals. Woo, you know what that means? If there's not a number I'm skipping, then I don't have a whole and I don't have a vertical asymptote, either one. We're going to remember that when we get to asymptotes. Let's see if this little fellow reduces. No, that x squared is not a factor in the denominator, so it doesn't reduce. Intercepts, if I plug in 0 for x, I get 0 for y. And if I plug in 0 for y, let's see if I get anything different. Doesn't look like it, does it? Multiply both sides by x squared plus 1. I have 0 over here, 4x squared here. So dividing both sides by 4, I get x squared equals 0, so x is 0. Got the same thing again. That's usually what's happened for me so far. Let's check symmetry. This is very much like the x squared minus 9. Every time I put in an opposite of x, I get the x squared back. So can you tell it's y-axis symmetry? If not, you can go ahead and plug it in and convince yourself. Asymptotes, no vertical asymptotes, because we're not skipping any numbers, we're using all numbers. Does it cross? We hadn't done horizontal, have we? Of course it's not going to cross one we don't have, so we better find it. Horizontal asymptote, when I divide lead term into lead term, I get a constant, which is 4. That means y equals 4 is my horizontal asymptote, because this is going to equal 4 plus some remainder divided by x squared plus 1 if I actually do the long division, and this will always trail to 0 as x approaches infinity. We've looked at that before. So y equals 4 is our horizontal asymptote. Now we'll check and see if we cross the horizontal asymptote. If we cross that horizontal asymptote, it means the y of the asymptote, which is 4, equals the y of f of x, which is 4x squared divided by x squared plus 1. We can clear fractions by multiplying both sides by x squared plus 1. I get 4x squared plus 4 here. These divide out and I have 4x squared. Subtracting 4x squared from both sides, I get 4 equals 0. Check my arithmetic, yep. And that's a false statement. It's always false. So I did not find an x when I set the y's equal. So that means it doesn't cross the asymptote. So I'll write no. And of course we'll come up with additional points as we look at our graph. So here's our graph. I have y equals 4 as my only asymptote, and the graph doesn't cross it. And I know we have the point 0, 0 on the graph. Well, you know what? I don't have a vertical asymptote dividing the graph in half this time, or in thirds. So I might just go a little bit to the left of the origin and a little bit to the right of the origin and see what happens. So if I plug in for x, maybe, why don't we do a 1, 2, and a 3, a -1, a -2, and a -3, and see what happens. If I plug in 1, I get a 2. If I plug in 2, you know what? I'm changing the form. I'm saying 3.2. For 3, I'm using 3.6. That means for -1, there's a 2. For -2, there's a 3.2. For -3, there is a 3.6 because of that symmetry. Now, why do you think I changed the way I was doing things? Well, you know what I did? I actually put that on the calculator this time because sometimes I like to check my graph with the calculator. Other times I just plain want to be sneaky and get other values figured out without having to do it by hand. So let's take a look at this on the calculator and see how I got those values. Okay, we're going to type in 4x squared divided by x squared plus 1. That means we need the denominator in parentheses for sure, and since a little bit's going on in the numerator, I'll just be on the safe side and just make sure I'm not going to goof up. So numerator in parentheses divided by denominator in parentheses, and that denominator is x squared plus 1. So x to the second plus 1, close parenthesis, and let's graph it and see what it looks like. That's an interesting graph. But I'm really interested in the table numbers. So second table, and you see where I got this: 0, 0, 1, 2, 2, 3.2, 3, 3.6. If I want 4, I've got it. I can round it to tenths, and that's 3.8. Since the number past, or the digit past the tenths place is 5 or greater. So that's how I got my values this time. I just decided I'd let the calculator do it for me. Plus, when I got my graph, I could check it. So remember what it looks like, and we'll see if our graph turns out that way. So let's go back to our slideshow and resume our points here. 1, 2. And negative 1, 2. 3. No, 2, 3.2, 1, 2, 3.2, and negative 3, 3.2. And then we also found 3 to be 3.6, getting a little closer to that asymptote, and negative 3, 3.6. Well, we already know we don't cross the horizontal asymptote. We checked it, so we just have to head toward it. So we do a curve, and then we do a little bit of a wiggle to head toward the asymptotes. And doesn't ours look like the one we saw on the graph just a few minutes ago? So if you want to be sneaky, you can certainly get your values from the grapher. I will just caution you though, I would, as a habit, always put the numerator in parentheses, always put the denominator in the parentheses, then I won't goof up when I actually need the parentheses. I've had several graphs on tests that indicated to me that people were getting the values from the calculator and they had not entered the function correctly in the calculator. So be very careful there. All right, let's move on to another one now. There's our graph for it. And we're going to graph f of x equals x squared minus 4 divided by x minus 2. I actually think we can do that on this screen. F of x equals x squared minus 4 divided by x minus 2. Our domain, x cannot be 2. I wonder if that means we have an asymptote there. Well, we've got to go through this reduce step. Do you remember that we can factor the difference of squares? And guess what? X minus 2 times x plus 2 divided by x minus 2. X minus 2 divided by x minus 2 reduces to y equals x plus 2, so long as we're not reducing 0 over 0, or we remember not to use 2 in our domain. Y equals x plus 2. Think back. What kind of graph do I expect with y equals x plus 2? Since x is to the first power, y is to the first power, do you expect a line? I hope you do. So what can we do? We can do a value. We can plug in 0 for x and get 2 for y. That's our y-intercept. We could go on and get about 2 more points, or we could say the slope is 1, the understood coefficient of x here. So we could write the slope as 1 divided by 1 or as negative 1 divided by 1. So we could graph our 0, 2, go up 1 over 1, up 1 over 1, so forth, down 1, left 1, down 1, left 1, down 1, left 1, so forth, until we get our line drawn. Then I have to remember that x cannot be 2, so when I get to 2, I draw an open circle there to show that it actually skips 2, 4, which is on the graph of y equals x plus 2 when we have no restricted domain. Wonder what that would look like on the graph. Are you curious? Let's graph it and see. Go to y equals, and let's see, what do we have in the numerator? So parenthesis for the numerator, x squared minus 4, x to the second minus 4, close parenthesis, divided by parenthesis for the denominator, x minus 2, close parenthesis. And let's have it graph. Looks like ours, doesn't it? Where's our hole? Well, you're not going to see it on this screen because of the way it does the pixels. But if I go to zoom decimal and work on this a little bit, I think we'll find our hole. Our problem now is our hole is way up there. So let's see if we can adjust our window to include that. We know that was 2, 4, so we need our y's to go up. What about a 5? Get a little above it. Maybe a 6 even. Get above it. Now let's graph it and see what happens. There's my hole right there. So using that decimal function, we can see that we have a line graph with a hole because x cannot be 2, and we have an empty hole because the problem reduced away to a line, but we still couldn't use the 2. If we could never use it, or if we couldn't use it in the beginning, we can never use it. So that concludes what we're looking at today. We'll continue graphing next time.